Okay, so we are continuing with the chapter probability. Uh, we are going to be doing this question. The result of the last 10 matches played by Maidstone United football team are shown in the table. So the outcome of the match, there can be three outcomes of the match. Either it can be won, or it can be lost, or it can be draw. Okay. So these are the number of matches played by this team. So the team won 6 matches, lost 3 matches, and 1 match was draw. On the evidence of their recent matches, what is the estimated probability that this football team will win their next match? So, guys, probability is used to make prediction. If we have sufficient data, we can use that data to predict the result. Okay, so you might have seen in the recent matches played between Pakistan and the opponent team that on your screen there they run an ad, and with that ad they tell you the match predictor. So Pakistan, let's say, is winning. The chances, last 5 overs are left, and the chances of Pakistan winning is, let's say, 60%. And let's say the other team, okay, the other team, the chances are 40%. Now, after 2 overs, when Pakistan has played really, really well, automatically the predictor is going to go high. So based on the previous data, predictions can be done. Okay. So over here, we have this data of this football team. If I want to figure out what is the probability that the team will be winning their next match, although the match has not been played yet, but I'm using the data to predict what is going to be the probability that they will win the next match. So what do you think the probability of them winning the next match is? So you're going to see how many matches have they played in total and how many have they won. Okay, so on the evidence of the recent matches, we are going to find the relative frequency. Okay, so you are going to find the relative frequency of winning. Relative frequency of winning is going to be 6 out of 10. That is 0.6, which means 60% chances there that they are going to win the next match. There is a 30% chance that they are going to lose the match. And there is a 10% chance based on their previous result that they are going to neither win nor lose, they are going to draw it. Okay. So if we want to give our answer as a percentage, we are going to multiply the answer of the probability by 100. Okay. All right. Now the estimated number of favorable outcomes. So you can use the probability to estimate the expected number of favorable outcomes from a series of trials. So if you have a number of trials, you can predict you can use the probability to estimate the expected number of favorable outcome from a series of trials. So expected number of favorable outcome is simply the probability multiplied by the number of trials. So for example, if there is a 60% chance that this team is going to win, so this is a 60% chance in one match. Okay, so you can multiply by the number of trials, you can get the expected number of favorable outcome. For example, a packet of broad bean seeds contain 150 seeds. The information on the packet claims that 9 out of every 10 seed will germinate. Ahmed sows a packet of broad bean seed. How many plants can he expect to grow? So on the packet comes with some kind of assurance. It claims that 9 out of every 10 seed is going to generate. So they are giving you the probability that 90% of the seeds are going to germinate. They are going to be converted into plants. Okay. So Ahmed has sown 150 seeds. So out of 150 seeds, how many are going to germinate? That's what you need to find. So you are basically finding the expected number of favorable outcome over here. Do you know the probability of the favorable outcome? Favorable outcome means what what does the question want? The question wants it to germinate. So what is the probability that a seed is going to germinate? What is the probability that the seed is going to germinate? Do you guys agree that it's 9 out of 10? That's the problem.
Yes.
So if I want to use this probability to estimate the result, the number of favorable outcomes, the expected number of favorable outcome out of 150. So all you are going to do is to find the expected number, okay, to find the expected number of favorable outcomes, which in this case is going to be the number of seeds that are expected to germinate. That's going to be the probability, that is 0.9, multiplied by the number of trials. The number of trials are your number of trials is the total number of seeds packet that you have bought, 150. So out of 150, how many will germinate? 90% of 150 is going to germinate. That is 135 seeds.
So can I just simply minus 15 out of 150 and get 135?
That's also fine. But since we are doing probability over here, this concept is going to be helpful, or what you are saying is also true, but this concept is going to be helpful in the later classes as well, that to find the expected number of the favorable outcome, okay, you always need to multiply probability of the favorable outcome multiplied by the number of trials. So I'll give you a quick example. Let's say there's a probability that I'm going to arrive at school on time. The probability of me arriving at the school on time is 60%, for example. Okay, that is 0.6. Okay, so for a period of, and that's the probability that I arrived on time on a single day. So if I give you the number of trials to be 30, so in how many days in a month I'm going to be arriving on time? So to find the number of days I arrive on time, that's going to be the probability of the favorable outcome, that is 0.6, multiplied by the number of trials. So 0.6 times 30, that is 18. So out of 30 days, students can expect that on 18 days, Sir Adam is going to be arriving on time. Okay. Now, what if my favorable outcome was, if the probability that I arrive on time is 0.6, so what is the probability that I am late?
12.
The probability is going to be 0.4. Okay, so if I want to
Yes.
figure out, if I want to find the expected number of days I am late, that is going to be the probability of the favorable outcome. Now the favorable outcome is that I get late, multiply by the number of trials. So that is 12 days. Getting the idea about for this?
So cannot we just divide 12 by 30 and get 0.4?
Yeah, but that's the probability. Now we want the number of days I'm late. So I'm going to multiply the probability of getting late by the total number of trials. So I get in a month, I'm going to be late for 12 days. And in a month, I'm going to be arriving on time on 18 days. Make sense?
Oh, so yes. So can we just directly answer and on the paper without doing any working?
Okay. So if your question is for 1 marks, okay,
Yes.
you can write there is always always in your exam, there is going to be a question and then there is a dash given. So if the question is for 1 marks, you can just write down the answer 12 days. That's it. But if the question would have been 2 marks, there must be some working required.
Okay.
Okay. Let's try this one now. Maria is going to make some cakes for a party. The cakes will either be chocolate, fruit, lemon, or coffee flavored. She knows that the flavors will not be equally popular. So she asked 20 of her friends to say which of these flavors they prefer. Okay, now are you understanding the question? She has a very smart move over here. If she wants to make some cakes for the party, okay, she's not gonna say, she is not thinking in those terms that okay, I'm going to make equal number of each flavor cake. Okay, so what she is doing is she thought of this idea that not every flavor might be that much popular. Okay, so what she did was she called her friends, 20 of her friends, and she asked which flavors do they prefer. So out of 27 replied that they prefer chocolate. Out of 24 replied that they prefer fruit flavor, 6 preferred lemon flavor, and 3 preferred coffee flavors. Okay, although coffee flavor should have been more, but fine. Maria is going to make 240 cakes. She has in her mind that she has a target of making 240 cakes, but now she is going to be making, she is not going to be making equal number of cakes. She is going to be making the number of cakes based on the result that she has got from calling her friends. How many chocolate cakes should Maria make? Okay, should Maria make? This means that she hasn't started making it. She's thinking to herself that based on this data, how much chocolate cake should I bake? So these are the number of trials, okay? These are the total number of trials. And you need to find the expected number of chocolate cake she should bake based on the data she has now. So what do you think, guys? What should be the expected number of chocolate cakes?
7 upon 20, 0.35, 35%.
Expected number of chocolate cakes. So you are going to multiply the probability of success, that is the probability of chocolate cake, that is 7 upon 20. Okay, multiply by the number of trials. The number of trials is 240. So out of 240 cakes, how many chocolate cakes should be made? So 7 upon 20 is the probability, multiply by 240. What's the answer?
84.
84. So she should bake 84 chocolate cakes. Okay. If she has intended to make 240 cakes, she can distribute the number of cakes based on the result she has got. Okay. Her friends like chocolate cakes the most. So she's going to make more number of chocolate cakes. Okay. For the remaining number of fruit cakes is going to be 4 out of 20 times 240. Similarly, lemon cakes are going to be 6 out of 20 times 240. Okay, and the remaining can be coffee cakes. Do you understand what's the use of probability over here?
Yes.
Any questions till here? Anyone?
No.
All right. All right. So I'm going to stop the screen right now. I want you guys to try this question. So there's a bias spinner. We have discussed the idea of bias and fair. This is a bias spinner. The bias spinner has 4 sections colored yellow, green, blue, and red. We say that the spinner is biased when the outcomes doesn't have equal probabilities. So as you can see over here that the probability of yellow is different from the red. So obviously there is some biasness involved in the spinner. The probability of the spinner landing on green is the same as the probability of its landing on blue. So they both have the same probability. So if this is X, let's say this is also X. What do you think the total probability is? What can we say about the total probability?
1.
The total probability is always 1. So you need to come up with an equation in X to solve. So the equation in X is going to be the equation containing total probability. So 0.2, probability of yellow, probability of green, probability of blue, probability of red. The total is going to be equal to 1. So this is going to give you an equation in X which can be solved. So when you solve this equation, what do you get?
0.32.
0.32. So the probability of green now is 0.32. The probability of blue is 0.32. Okay, so probability that the spinner lands on blue is 0.32. If the spinner is spun 300 times, what is the value of 300 times tell you? The number of trials. How many times would you expect it to land on red? So out of 300 times, based on these probabilities, how many times would you expect it to land on red? Expected number of times it lands on red. It lands on red. That's going to be equal to the probability of red, that is 0.16, multiplied by the number of trials, that is 300. So 0.16 times 300 is 48. Okay, so this means that out of 300 times when the spinner is spin, we are going to expect, based on the probability, that the spinner is going to land on red 48 times. Is the question clear?
Yes.
All right. Now, I have the answers over here. Okay, let me just...
So how did you get 0.32 in the previous question?
0.32. Okay. So you add all the probabilities. So 0.2 plus x plus 0.16 equal to 1. The total probability will always be equal to 1. So you add these two and minus it from 1, subtract it from 1 and then divide by 2. So you get 0.32. Okay.
Yes.
Okay, just give me a minute. I'm just erasing the answers over here. I want you guys to try this question on your own. So a box contains X red marbles, X plus 3 yellow marbles, and 4X minus 15 blue marbles. Find an expression in terms of X for the total number of marbles in the box. So the total number of marbles in the box is going to be the sum of all these marbles. Total number of marbles is going to be equal to the number of red marbles plus the number of yellow marbles plus the number of blue marbles. And then you can simplify this out. It's going to be 6x minus 12. Okay. Then the question says a marble is drawn at random from the box. Write down an expression in terms of X for the probability that the marble is blue. So if you're picking up one marble randomly from the box, what is the probability that it's going to be blue? So do you have the blue number of marbles? The blue number of marbles is 4x minus 15. And the total number of marbles is 6x minus 12. So the probability is going to be 4x minus 15 upon 6x minus 12. That is the probability of picking up a blue marble. Is everyone with me till here?
Yes.
Then the third part says, given that the probability in the second part is 1 upon 2, which means that the answer to the probability on the second part is 1 upon 2, find the value of x. So you're going to use the equation. You're going to form an equation in terms of x and solve it. The question says that the probability of blue is 1 upon 2. So just cross multiply and solve this. So is x coming out to be 9? Everyone is getting
Yes.
x as 9?
Yes.
Okay, great. Just give me a minute. So we are doing now probability of a single event with and without replacement. So a large tank contains 36 goldfish, of which 8 are red and 28 are black. One goldfish is picked at random. What is the probability that the goldfish is red? So the probability of getting a red goldfish is going to be 8 upon 36. Is that correct? 8 upon 36 is 2.9. Now, if the red goldfish,
Yes.
the second part says, if the red goldfish is put aside. Okay, now imagine this. If you have 36 goldfish, out of which you picked up one randomly, okay? You're not looking at the color and picking it up. You pick it up randomly and it turned out to be a red and you kept it aside. So how many number of goldfish are remaining in the bag right now?
35.
35. Out of those 35, what is the probability that the second goldfish that you are going to pick is going to be a black goldfish?
28 over 35.
Yeah, now there are total of 35 black goldfish, out of which 28 are black. So the probability is going to be 28 upon 35. That's 4 over 5. Okay, so this is the experiment done without replacement. Okay, if only the black goldfish is put back into the tank, find the probability that the next goldfish picked is red. Now, if you have put back the black goldfish, okay, so how many goldfish are still in the bag? In the tank, sorry.
7.
How many?
7 over 35.
No, how many are in the tank right now?
35.
35, okay? Because you picked up red and you picked up black. So, right, initially the tank is going to have 33, sorry, 30, 34. Okay, now you put up the black goldfish back into the tank. So that means now the tank is going to have 35 goldfish. Out of this 35, what is the probability that the next goldfish picked is going to be red? So out of the 35, how many red fishes are there still in the bag?
7.
7. So the probability is going to be 7 upon 35. Do you guys understand this?
Yes.
Okay. Just give me a minute. Okay, now we are going to be doing probabilities of combined event. If two events are being combined, okay, and they are independent events. First, understand what does the word independent means. Independent means that the events, the probabilities are not being affected by the outcomes. So if A and B are the two outcomes, the probability of A is not getting affected by probability of B, event B, or B is not getting affected by A. Okay, so we say that they are independent events. And if we want to find the probability that they are going to happen, okay, so that the probability of event A and B is simply the product of probability of A times probability of B. Two events are independent if the outcome of one does not affect the outcome of the other. Okay, for example, You take up a coin in one hand and take up a dice in one hand. First of all, first you toss the coin. The outcomes can be head or a tail. And in the second hand, you had a dice. You're rolling a dice. And the outcome can be 1, 2, 3, 4, 5, 6. Will the outcome be affected by, will the outcome on the dice get affected by the outcome on the coin?
No.
No. Okay. And vice versa, the outcome on the dice is not going to be affected by coin, and the outcome on the coin is not going to be affected by the dice. So the example can be a fair coin will always have equal chances of landing on either side. Okay. A fair coin will always have equal chances of landing on either side. Now, for example, you are tossing the coin 2 times. Okay, that's your coin. Either you can get a head or a tail. And it's a fair coin. So it has equal chances of landing either on the head side or a tail side. Okay, no matter how many times you uh, no matter how many times you flip it. So if you flip it once, you can get a head, and the probability of getting a head, let's say you flip it and you get a head. So probability of head in the first time on the first trial is 1 upon 2. So now when you're going to flip it and you want head, what is the probability of getting a head on the second trial? It's still 1 upon 2. It's not affected by whatever the outcome was on the first trial. So you're going to say that getting a head on the first trial and getting a head on the second trial are independent events. They are not dependent on each other. The probabilities are not going to be affected. Okay. So try this question. A fair coin is flipped twice. What is the probability that both outcomes will be tail? You want a tail.
1 upon
You want a tail in the first attempt and you want a tail in the second attempt as well.
2 upon 4.
Okay. So first, let us be clear on this, that flipping the coin twice will generate two events. Okay. Flipping a coin once and flipping a coin twice. So if I want the probability of getting a tail on the first and the tail on the second, this is equal to probability of getting a tail on the first multiplied by the probability of getting a tail on the second. Okay. So what's the probability of getting a tail on the first attempt?
1/2.
1/2. What is the probability of getting a tail on the second attempt?
1/2.
Okay, 1/2. So the outcome is, the probability is going to be 1 upon 4. Now, can anyone logically explain why the probability over here, why the probability of both events happening is less than this event? I mean, if I was just using one coin, then the probability of getting a tail was 50%. Okay. But now when I'm using two coins or flipping the same coin twice, the chances of getting tail 2 times reduces. Can you visualize this concept? Because now other factors are involved. Now other options are possible as well. For example, if I toss the coin 2 times, I can get 2 heads, head and a head, or I can get head in the first and tail in the second, or I can get tail in the first and head in the second, or I can get tail in both. Previously, when I was just using one coin, there is only one, there are only 2 outcomes. Now there are 4 outcomes. Okay. So getting 2 head is 1 out of 4. The probability is going to be 25%. Getting 2 tails is also 1 out of 4, 25%. And getting 1 head and a tail, either you can get head in the first attempt and tail in the second, or you can have a tail in the first attempt and head in the second. So that's 50%. 1 upon, that's 2 out of 4, that is 1 upon 2, which is 50%. Okay, that's 25%. This is 25%. Getting it? And whenever you multiply probabilities, okay, the answer, the product is always less than the individual values, because these are values less than 1. So the product is always going to be less than 1, less than the previous answer. Okay, let's try this one. An unbiased 6-sided dice is rolled twice. What is the probability that both dice land on a 6? So getting a 6 on the first dice and getting a 6 on the second dice, are these independent events or dependent events?
Independent.
Independent events, because getting a 6 on the second die is not being affected by whether we get a 6 on the first dice or not. So these are independent events. For independent events, please remember that probability of 2 events occurring together, A and B, probability of A and B is the same as probability of A times probability of B. So over here, if you want to get 6 on both the dice, this means that you want 6 on the first die and you want 6 on the second die. So you are going to take the probability of getting a 6 on the first die multiplied by the probability of getting a 6 on the second die. What's the probability of getting
1
a
over
6 on the first die? 1 over 6. Probability of the second die is also 1 upon 6. So that is 1 out of 36. Okay. So if you roll a die and you get 6 and 6, that is 1 out of 36 time. So the probability is 1 out of 36. Okay. This means that if you were to roll it 36 times, there is a chance that on one time you get 6 and 6. Is the answer, is the working for the first part clear?
Yes, but we can get more than 1 in 36 trials. We can get 5, 10.
Yeah, that's true. But over here we are expecting this on this is a theoretical probability. The actual probability might be different as well, like it. Okay. Remember, we did theoretical probability and we did relative frequency. When you are actually going to do the experiment and record the number of times you get the 6s together, that's going to be called the relative frequency of getting a 6 based on your experiment. Right now, this is just a theoretical probability. Okay, now part B says the first dice land on a 6 and the second does not. So we want the first dice to land on a 6 and the second dice to not. So I don't want this 6 prime means not a 6 on the second die. So will the two events be independent?
Yes.
So probability of getting a 6 on the first and getting a 6 and not getting a 6 on the second dice is going to be equal to probability of getting 6 on the first times probability of not getting a 6 on the second. So what is the probability of getting 6 on the first die? 1 upon 6.
1.
And what is the probability of not getting a 6 on the second die?
5 over 6.
5 over 6.
5 over 6. So the result is going to be 5 out of 36. Okay. Because we can get 6 with 1, we can get 6 with 2, we can get 6 with 3, so 6 with 4, 6 with 5. Okay, so there are 5 chances out of 36 options. Is the working for the question clear?
Yes.
Okay, now the next example, next thing that we are going to discuss is the mutually exclusive event. We say that the events are mutually exclusive when they cannot occur together. Okay, mutually exclusive events cannot both occur at the same time. Okay, for example, when you flip a coin, it is not possible for the outcome to be both heads and tail. Either you are going to get a head or you are going to get a tail. If you flip a coin once, you are only going to get one outcome, that is either a head or a tail. From a single coin, you can't have both the outcomes. So getting a head and or a tail in this kind of event, these two events are basically mutually exclusive. Getting a head is one event, getting a tail is another event. The two events are mutually exclusive because they cannot occur at the same time. So if the question says, if there are two events, for example, A and B, event A and event B, and you are being asked the probability of having A or B. A or B means either A can occur or B can occur. They cannot occur at the same time. So probability of A or B is going to be equal to probability of A plus probability of B. Okay. Okay. So for example, if I roll a dice and it is a fair dice, it has six options, six-sided fair dice. If I ask you what is the probability of getting a 4 or a 5, so you know that 4 and 5 on a single die cannot occur at the same time. So getting a 4 or getting a 5 is mutually exclusive. If I want to find the probability of getting a 4 or a 5, so that's going to be equal to getting a 4, the probability of getting a 4 on the dice, or getting a probability of getting a 5 on the dice. So probability of getting a 4 is going to be 1 upon 6 plus getting a 5 is going to be 1 upon 6. That is going to be 2 upon 6. Do you understand this example? Are you clear what are mutually exclusive events? Any questions still here?
No. So in the questions, are they going to be writing which type of an event is it?
No, you are going to identify. For example, if they're talking about a coin and they are talking about a single coin being flipped and they are asking the probability of getting a head or a tail. So both cannot occur at the same time. So they are mutually exclusive event. Okay. The example that I just gave it to you, for example, if you're rolling a dice, what is the probability that the score on the dice is either of is a 4 or a 6? So you are okay with getting a score of 4 or getting a score of 6. Okay. For example, you throw a dice, you can get 1, you can get 2, you can get 3, you can get 4, 5, or 6. Now the question is, what is the probability of getting a 4 or a 6? So
1/6.
getting a 4 is 1 out of 6. Getting a 6 is 1 out of 6. So that's going to be equal to probability of 4 plus probability of 6. That is 1 out of 6 plus 1 out of 6. That is 2 out of 6. Okay. And out, if I don't do it like this, and if I have the option in front of me, so would you agree that if the question is what is the probability of getting 4 or a 6, this means that I'm okay with getting a 4 or getting a 6. So these are the two options out of the 6 options. So the probability is going to be 2 out of 6. Make sense?
Yes.
Okay, now try this one. An unbiased die. Guys, unbiased means fair dice. An unbiased dice is rolled twice and the scores are added. What is the probability that the total score is 3? So we are
So
talking about, sorry,
is it a six-sided dice or four-sided dice?
it's a 6-sided dice. Okay.
Okay.
So a fair dice is rolled twice and the scores are added. The scores are added. What is the probability that the total score is 6? Okay, how can you get a total score of 6?
Is it 3 or 6?
Sorry, the total score of 3. My bad. So sorry. The total score, you need the total score of 3. And there are 2 dice.
So you roll 1 and 2.
1 and 2. Okay. So if you get a 1 on the first dice and 2 on the second dice, your score is going to be 3. Is there any other possibility?
2 on the first one and 1 on the second.
Yes. The other possibility is that you get 2 on the first die and then 1. So if I want to find the probability, I know that the score is going to be 3 when I get 1 and then 2. So what is the probability of getting a 1?
1 over 6.
1 over 6. And then I want 6. Sorry, and then I want 2. So that's also 1 upon 6. Okay. So that's going to be 1 upon 36. Okay, now what if I want probability that I get 2 on the first die followed by 1. What is the probability of getting a 2 on the first dice?
1 over 6.
And 1 on the second dice? 1 upon 6. So that's going to be 1 upon 36. Okay. Now I want the score of 3. What is the probability that the total score is going to be 3?
Over 36.
Yeah. So probably that the total score is 3. So you can have this option, or you can have this option. You can have probability of 1 then 2, or probability of 2 then 1 followed by 1. So the probability is 1 upon 36 plus 1 upon 36. That is 2 upon 36. Okay, which is 1 upon 18. Is everyone clear till here? Is the question clear?
Yes.
I could also have done this question using a possibility tree diagram that I'm going to explain in the next class, but I'm just going to show you the working over here. Possibility diagram is a diagram that shows options, that options when 2 trials are taking place. So I can get, these are the possible outcomes on the first dice. These are the possible outcomes on the second dice. Okay. You're going to observe that if the score is calculated by taking the score on the first die and the second die and adding it up, so 1 and 1, the score is going to be 2. 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, and 7. And similarly, if you're going to keep on adding this is what you're going to get. Okay, so if I ask you how many total outcomes are there, how many total scores can be possible? So if you count this up, there are 36 outcomes. Okay, if you count these numbers, there are 36 outcomes. And what is the probability of getting a score of 3? Okay, the 3 is only over here. So out of 36 outcome, you can get a score of 3 2 times. So the probability of getting a total score of 3 is 2 upon 36 or 1 upon 18. So I'm going to be starting with the possibility diagrams in the next class. Is everyone clear till here?
Yes.